So we were talking about rolling two dice, and the first die is a 2, and the sum of the die is less than or equal to 5. So we would want to take these 6 pairs right here. That's where the first die is a 2, 6 out of 36, plus the sum of the die is less than or equal to 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then we have to subtract out these 3 because we've overcounted them. So on the next slide here, we've got our 6 out of 36 plus our 10 out of 36, but these 3 have been included in both the 6 and the 10. So we have to subtract those out. Now the complement of an event is everything that are not outcomes of E, everything in the sample space that are not in event E. And notice we denote it with a capital E and a superscript of a C. Here's a picture of it as a Venn diagram. So let's take a look at an example. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability that a randomly selected household does not own a dog? Well, our entire sample space, that would be 1 minus those that own a dog. So 0.684 is the complement of people who own a dog, or in other words, people who don't own a dog. Now here's a frequency distribution. We've seen these before. What's the probability that a randomly selected resident has to travel 90 minutes or more? Well, 90 minutes or more is just this one here. So 4,895 out of the total, 393,186. So that is just plain old probability. Sometimes it's called marginal probability. But now we can answer the question quite easily. What's the probability that they would travel less than 90 minutes? Now you could add up all of these numbers here and divide by 393,186. But why would you do that when it's much easier to use what you've already figured out? So the complement of 90 minutes or more is the same as less than 90 minutes.